My name is Patryk Omiotek, and I'm a software engineer at Intiv and also IT trainer in InfoShare Academy, and also an organizer of local events in Lublin. And today I will tell you something about machine learning. As you already know, we can use machine learning in JavaScript. Here's the definition: is the field of study that gives computers the ability to learn without being explicitly programmed. Definition from 1959. So machine learning can be used, of course, for classification problems. So, for example, when you have your Gmails and Gmail decided to give new email to inbox or classify it as a spam. In regression problem, where we have a lot of coefficients and we have model and we need to fit our coefficients. In clustering, for example, in DNA researches, and in anomaly detection, for example, in banking sector. So machine learning is used basically when you have labeled data and you have new set of data and like to get predictions about new data. What about machine learning libraries and frameworks? So there is a lot of, for example, NumPy, Pandas, Matplotlib, Seaborn for graphs and for representing data, and also scikit-learn, TensorFlow mentioned before, Keras, PyTorch, and Spark with its mlib library. But what about machine learning in JavaScript? Of course, the first question: is there a sense for make machine learning in JavaScript? Why not? Why not? JavaScript is just programming language, but it works in other environments, in Node and in the browser. Some community, of course, created a lot of machine learning libraries, like meet.js, which allows you to make operations on matrices, brain.js, synaptic, which is really cool library, natural, conv.js, ml.js, synaptic, webDNN. Right, here is a screenshot from meet.js, so you can make simple operations on matrices. And there is much more libraries like Face API, which detects faces and classify which person is on a particular picture. There is also CLM track. Synaptic is used, for example, for building artificial neural networks. Someone created a game, created a neural network with two input neurons with one hidden layer, and output layer decide if flap or not to flap using this build. And they also created a game, and they are copying features from the most strongest build in each particular iteration, and after that these builds are more accurate to win this game. 1 year ago at Meet.js Summit 2017, I have only one t-shirt. I tried to explain how to use TensorFlow in Node.js, because there were a lot of tries, and also people from Google were writing on internet forums that it's not so easy because they need GPU acceleration and WebGL, so it wasn't so easy. And 1 year ago I was talking about, we will see in the near future, maybe someday there will be TensorFlow.js for JavaScript developers, and from April this year we have TensorFlow.js, so we can use it in Node and we can use it in the browsers. And my first reaction was like that. Yeah, I hope you too. So people from TensorFlow decided, of course, to create some tutorials and some examples when you can use TensorFlow. They created a game for the mobile clients, because mobile clients have the browsers, and browsers have access to camera, to many other sensors. So using this game, they create a classifier, and using camera you can decide if something in the physical world, for example clock or banana, passes the classifications. They also created PoseNet, which detects your parts of the body. And in the browsers, you can also use another pre-trained models, because models can be loaded from the net. But I don't have internet connection. But believe me, then that in this example, JavaScript code running in the browser are downloading a pre-trained model, and you can upload pictures, and classifier decide if it's cat, dog, or another another thing. Do you like Pac-Man? Who like Pac-Man? Who likes Pac-Man? Is there someone brave who would like to play Pac-Man with me? Okay. I'm so sad. So maybe later I will send you an example. In this example, you can learn neural networks giving images from your camera. So you, for example, you can move your head up, down, left, and right, and network will learn from moves of your body, of your head, basically, and you can play in Pac-Man using only your web camera. Okay, what is behind the scenes in this TensorFlow? What's the starting point? It's a tensor. It's a central unit in this TensorFlow.js and also TensorFlow implementations in Python. A tensor is something like vector in maths. It has its own values and shape. Shape defines how many rows and how many columns we have. So in this example, we are creating tensor with these values, and our output is something like that. So it's a two-dimensional array with 2 rows and 3 columns. What's important, we can also pass an array of arrays and use functions like tensor 1D, tensor 2D, 3D, and 4D for better code quality and so on. So in this example, we have something like that. We have also functions like zeros and ones, which are really useful in mathematical operations. As you can see, we have only zeros and ones. Awesome, right? Variables, because tensors are immutable. We cannot change values of the tensor, so they decided to create variables, and using variables you can change values. What is so important? Because in the learning process you need to change values in each iteration of your, for example, coefficient or your data. So in this example we have a tensor with zeros, biases, and we are using tf variable with initial values, so we have only zeros. But in these lines we have assign function, so using that we can change our values. And now we have something like this. Operations, so if we have tensors, we have variables, we'd like to make some operations, for example, add some tensors, add values of some tensors or variables, multiplicate, subtraction, and power. So in this example we have predict function, and with tidy function we have tf scalar with some input, and we are creating this a x to plus bx plus c function that way. So below we are defining scalars, and we are using our model to predict some values. It's simple example, and I use tidy. Tidy is used for making up blocks for pure GPU memory. So you should remember to clean up after your operations. So another example, popular in machine learning world, is a regression problem. So when we have a set of data, and these data are drawn, for example, at this plot, we can use model, a cubic function, for example, that way, and define some variables, A, B, C, D, right? It's coefficients. And our model looks like this, similar like in the last example. Because we choose random values for these coefficients, we have, of course, random chart like in this example. And our goal is to train our model to find the best fit values for our coefficient. To do this, we need to define some three things. First one is our loss function, which will create a difference between our values and predicted values. And for this is used a squared error, for example, an optimizer function, which will be decreasing our loss, because less loss is better. We're looking for something like that, and we are going to create training loop. Our loss function, for example, we can use this squared error function known from the math, from the studies, or from the school. We should define our learning rate and use optimizer. One of the optimizers, the most popular, for example, is gradient descent with learning rate. So this is time for creating, for define train function, train loop. So in some number of iteration, we minimize our loss, right? So here is the whole code. And after these 10 or 12 lines of the code, we have values of these coefficients predicted, and it looks like this, right? We have our data set, we have random choose values, so each time we have another function, and our model is learning and looking for best fits. So you know how to create regression. I mentioned about this learning rate. You need to be careful, because it's very important to to choose a value which is not less, or it's not big. You should choose, for example, something between. So if you are using Sigmund function, which has values between 0 to 1, I think it's good for start for linear regression. Why? Because your models could be underfitting or overfitting, and if you have fitted model, you could get something like that. For giving new data, your model can predict that Chihuahua and Cookie are looking the same, right? We as a human can make a mistake. What? Okay. I was talking about low-level API in TensorFlow. We have also higher level API in TensorFlow.js, and we have layers. So layers is a I will show you other example. One of the most popular examples in for beginners in machine learning is amnesty dataset and iris dataset. In iris, we have three kinds of flowers, and each flower have its own features like sepal length, sepal width, petal length, and petal width, and we have three species. It's setosa, virginica, versicolor. As JavaScript developers, we can, of course, use JSON format file. To start with this example, we need to make some imports. So we are importing iris, the whole dataset, and testing data, of course importing TensorFlow and bindings for Node if we are using Node, and in this example we will be using only Node. What we need to do is to convert our data, so prepared them for our training, build neural network, train our network, and test it. First thing, we are setting our data, so each input is an array of values. It's this petal and settle values. And in TensorFlow, we just mapping these values from JSON file. What about output? So we have three flowers, and each flower will be 0 or 1. So for example, if in the second position I have 1, it's Virginica. So our output data we can define like this, simply ternary operators. And similar to training data, we are defining our testing data. Okay? So let's build a network. In TensorFlow, it's really easy. The most popular model for do this is tf.sequential, and we are define new layers. First layer have shape of 4 because we have 4 inputs. Sigmoid is a function of activation when our layer should pass our data to other layer with some weights, and we have at the output 5 units because we'll get 5 neurons. This is the Sigmoid function which I mentioned before. Sorry. And we have similar network but only one hidden layer, and in the input layer we have 4 neurons and have output which defines which flower we have. So it's the last layer, this output layer, and what we need to do, of course, is to compile our model. So in linear regression I mentioned about loss function and optimizer. We also using same mean square error in this example, and we are choosing optimizer for this example. Good optimizer is an add-on with learning rate defined in the last line. Last but not least, we need to train our model. So we have fit function and pass training data, output data, number of iteration we have to provide, and after this operation our model is able to predict our results at testing values, and of course after this line add new set of data. What's next? One of the examples for machine learning engineers, of course, amnesty. It's similar to this example, but there is an shape 28 pixels and at 28 pixels with one color dimension, because this set of digits is only white and black. If you have color images like from the browser, third param is three-dimensional color, RGB, right? And the whole play is to convert our image to tensor, to an array with these 3 dimensions. So you can check TensorFlow examples after these presentations from TensorJS website, and try to train your models. I think it's the end. So thank you very much.
Okay, so going to questions about the talk. There's a question, because if you have a job offer, right? They are always telling about you need to know frameworks X, framework Y. I'm not going to name them. How likely is that a typical JS dev will need to know TensorFlow.js?
I haven't seen that type of offer so far.
But what do you think, like in 5 years? I know all of us are going to do machine learning in the browser.
Sorry for that.
No worries, it's fine.
You know what? I'm not sure because at this moment we can use TensorFlow for games. So, for example, for the media industry. So, in this stuff for games, from advertisement and also for educational games for chills. So maybe in these areas there will be a lot of projects.
Okay. Another question that we have is what kind of real-world problems and applications could you imagine for machine learning in the browser?
So the basic thing is that your data are staying in your browser. So some people don't want to share their data, or for example, don't want to get this data. I'm talking, for example, from companies.
Could you, yeah.
From companies, sorry.
Oh, it was on, but it was too far.
Okay. Companies from,
yes, now it's
from banking sector or telecoms. They making some applications which will be working only on the front end side. So maybe it's a case.
Okay, speaking of front-end, because there's also one question which was also asked during the previous talk, is that if you use machine learning in the browser, which means the client gets to download all of this, is there any risk in kind of doing machine learning in the browser? Because like I can get a model from a company and potentially steal it. Like imagine if I got a Facebook machine learning model, I'm sure it would be useful.
Sure, never trust your users.
Yes. That's the lesson you need to take from meet.js. Never trust your users. Thank you very much, Patryk.